So my name's James Duke. I'm in our professional services group in Google Cloud, specifically in our strategic cloud engineering group. I'm here with my colleague Shahid.
I'm Shahid. I'm also part of the professional services group, also a SCI, strategic cloud engineer.
And we're going to talk to you today a little bit about embarking, the journey towards containerizing your workloads. So it's a few different pieces to this talk. So we just want to talk through some of the things that we're actually going to cover during the session. So the first thing we want to talk about is what is a container, what does it give you, and cut through some of the jargon, get to some of those buzzwords, explain what some of those are. We'll cover a little bit about the business benefits. What does containerization get you? Why would you do containerization? What can you do that you couldn't do before? And a little bit about a roadmap. How do you get from essentially no containerization to full containerization? And how would you start at any point along that journey? And so we're going to take you through those things. We're going to try and do a very conversational style here between the two of us, which hopefully should keep things interesting. So why don't we start off with a little bit about containers?
Yep. So let's start with what is the big idea behind containers? Why do we need them? And how do they help us? So you may have heard a lot of buzzwords associated with containers. So what we're trying to do here is make you understand why these are associated with containers. So we'll revisit them once you've understood what containers really are. So this is the sort of layman's definition of containers. So not very technical, but technically correct still. So containers is about two capabilities. The first thing is the container technology allows you to package your application, and everything that application needs could be the configuration, any libraries that it needs, any runtimes, like if you have Java or Python, it needs a runtime to run the application. So packaging all that together into one bundle, and that bundle is called an image. So the first capability is the ability to create that image. And then the second part is ability to run that image as a process in an isolated environment. So isolated means that it's cut off from other processes running on the same host, and the resources it can use is limited. It cannot just run away with all the resources. So to understand that a little bit more, let's look at the history of containers, as well as how do applications typically run on a host. So the operating system is a key component running on a computer, and it has a number of components. The core part of the OS is called the kernel, and that's the minimum sort of software you need to run on a computer and be able to use it. Then you might need system modules, you might need utilities, tools that support your application or help you manage that machine, but the kernel is the core. That's the minimum thing that you need. So when the applications sort of run, they are sharing a lot of these resources. They might be using shared libraries. They can bring their own, but they might be sharing libraries with other applications that are running on the same host. Similarly, they're time slicing the resources, the CPU, and sharing the memory as well. And if one process runs away with the memory, it can starve the other processes running on that machine. So when you're sharing a host with regular applications, these are some of the issues that can creep up. The other thing that can happen is that the shared libraries, different applications may need different versions of those libraries. So if one application changes the library that's installed, it can interfere with other applications. So you have things like, hey, this ran fine on my machine, or this runs fine in development, and you take it to test, and it starts failing, and you can't figure out what's going on. So to get around that, you have a number of options. The first option is...
Before we jump into the virtualization piece, I'm seeing it. I'm seeing the post-lunch coma happening here. So let's get a little bit of audience participation, get some energy back into it's not really a room, but the booth, I guess. So who here has used a container? Excellent. Who here has built a container? OK. Who's used a container orchestration system like Kubernetes or... Yeah. Well, that's a good number. That's a good number. Who has moved an application from like a VM environment to a containerized environment? Okay, good, good, excellent. So that tells me one thing. We're right at the sweet spot here. we can cover this a little bit about containers, and then we're going to spend the majority of the time talking about the journey towards getting there. So excellent. And I'm already seeing more smiles and energy in the room, so that's good stuff. Let's get stuck into virtualization.
Yep.
So Shahid talked us a little about the kind of the old school way, right, where we have an operating system and libraries and all that kind of stuff. The next step on the journey is virtualization. So we're not quite at full containers yet, but we have the ability to break up a physical machine, a physical host, into a number of virtual hosts, which solves a number of those problems, right? We have limits on CPU and RAM usage. We have isolation between things. But there's a lot of overhead, right? Because now, as you see here, right, 4 kernels for 4 VMs. It takes a long time to boot a kernel. A kernel uses a lot of overhead, a lot of actual physical resources on the host. And so there is a limit to how much of the actual usable computing power you get out of a machine when you're using virtualization. So, and they're also slow to start, right? Because you have to boot a kernel. Booting the kernel can take a long time. So you want to spin up a new VM. There's a time component to that, which will reduce the speed at which you can scale. So it becomes a limit on scaling. So how do we solve that problem? Well, one approach is containers.
And so container is another type of virtualization, essentially. What we're doing is we're sharing the kernel. So we're not dividing the actual host into virtual machines. We're just setting up some boundaries around processes, and hence the word container. We're containing each process in its own sort of boundary, sandbox, if you will, and using the mechanism in the kernel to sort of limit the resources that each of that process can take. So it's sort of lightweight virtualization is the other term that's used as well. And whatever you do inside the container stays there, and any changes that you make, any libraries that you bring into the container do not impact any other processes running on the host. So let me just show you guys a running container. I'll just do a brief demo. So let me just reconnect here. It seems like I got disconnected.
Classic.
So what I'm doing is I have a Google Cloud VM, which can run containers. So I'm just logging in there. Seemed like my session timed out. And what I'll do is I will run a container, and I'll show you what that container looks like from the point of view of the container when you're inside the container, and how it looks like for the other process on the host. So let's just... So what I'm going to do is I'm going to use Docker, which is a container runtime, and run up an image, the Nginx image that you guys might be familiar with. So what I'm doing here is I am starting that process. And what you will see is that image is now running. So let's see what that looks like from the point of view of the host here. So I'm going to look at all the processes that are running on this machine. And what you'll see is that there are other things running there, but there's this Docker daemon, and that is running the Docker runtime, the container runtime, and you'll see that the Nginx is actually running in that process tree. So, and you can see all the other processes that are there as well. Now what I'll do is I'll just attach to that container. What you can do is you can attach to a container and essentially start a shell command inside the container. So that's what I'm doing. I'm just attaching to that and executing the bash shell. So what you'll see is my command prompt has changed, and now I'm in the context of that container. So any commands that I run here are running inside that container. So if I look at the file system, it has its own file system. And if I run that ps command in here, what you will see is you'll see a very limited set of processes. On the host, you saw that you had all the other processes that were running on the host. But from the container's point of view, it sees itself as the only process. So it sees the ps command that I ran, the shell that I'm in, and the Nginx, which we actually wanted to run. So this shows you how the processes are isolated. So within the container, it cannot access any of the other processes, and it's sort of isolated from those. So that just shows you, what a running container actually looks like. So just to recap quickly, the different ways of running applications, the traditional way is shared hosts. And we saw the problems with that. There's no isolation between your applications. Things that one application does can impact the other applications. If you have to prepare the host to run the application, your libraries have to be a particular version. If they're not, if your tools are not the right version, you might have issues. Then on the other end, we have the virtual machines, which provide a very high level of isolation. You can customize each virtual machine to the exact sort of specs that you need. But the downside is that it's expensive and inefficient, and virtual machines cannot be easily resized. You cannot increase the size of a virtual machine that easily, and it's generally a little bit harder to manage. But they do provide very high isolation. Containers provide sort of a middle ground where it does provide the isolation you need. You can install whatever libraries you need inside the container image, and that way your application will have exactly what it needs and only what it needs. You don't want to put a lot of extra stuff in there, and that way there's less overhead, and you can use the same host to run them to host more than one application.
It's always the way. The password's always wrong when someone else is looking,
yes.
right?
I had, yeah. So they provide a good sort of middle ground where they provide the isolation that you need, but they're nimble and lightweight. So with that, we can revisit some of the buzzwords, and you'll hopefully understand it a little bit better.
Yeah, so we promised at the beginning to cut through the buzzwords. We just used a whole bunch of buzzwords in that description. So let's revisit them and really nail them down. We talked a lot about lightweight. So containers are lightweight. You'll hear this a lot. What we're really talking about there is they contain only what they need. So when we said the VM, we had all that extra stuff, right? We had all the things that the operating system needs, the kernel, the dependencies, libraries which likely are never used by your application. A container doesn't have any of those things, right? It just has the bare minimum that you need to run.
Yeah, and that provides an extra benefit that you don't have any tools that if someone, to be misused, it reduces the attack surface. So if you had some rogue process running in your container, it has less tools at its disposal to sort of wreak havoc in your VMs.
And at a very simple level, it uses less resources, which means you can run more of them, right? You can run more containers on a given physical host than you can run VMs on a given physical host.
Yeah.
They're also portable. You can move them around easily.
Yeah.
Right?
And we'll show you that once you've built your image, you've done the hard part, and that image is very portable. Since the image contains everything you need, all you really need is is sort of a host to run it. So you need compute and memory, and you can run it pretty much anywhere.
And that, we're going to focus very much on Google's platforms today, but that's true across all sorts of things. Right? You can pick up an image and move it to another host, another platform, another provider. It just has it has the ability to be moved around very easily. And partially because of the lightweight, they're fast, right? I said earlier, overhead from a VM, you have to wait for the kernel to boot, which can take a long time. None of that with a container. You start a process, that's how long it takes to boot the container. Plus, of course, anything that the container needs to do for startup, of course. But the actual container itself runs much, much, much faster than, say, booting up a VM, which means when you're doing that portability, there's no penalty in the overhead of starting up that machine, right? You don't have to wait 2-3 minutes, whatever it might be, to shut down and restart a VM. It can be just like that.
Yeah. So you can scale up faster as well. Since you can share the host, you can run multiple applications. So your host, a new host, does not necessarily have to be spun up. You can use the same host and quickly start new processes to take on additional load. Yeah.
That's the buzzwords.
Yeah.
Make sense? Cut through? Do you feel sufficiently cut through those buzzwords? Excellent. Good stuff.
All right. So let's see what it means for your business. Why do you want to run containers now that you have a basic understanding of what container technology is? So we see containers as sort of an enabling technology. The benefits will come after you've started using containers. It's sort of a price of admission, if you will, or price you have to pay to be able to use a lot of the other things. And once you've containerized, you have a wide variety of things available to you. You can go from, you can deploy containers on bare VMs, what is also known as infrastructure as a service, or you can move to a more managed service like Kubernetes engine, which is typically known as a platform as a service, or you can go to App Engine and serverless offerings that are now showing up in the marketplace. So it allows you to move from one to the other pretty much seamlessly and effortlessly.
I mean, more or less what we're saying here is all those things that we just said a moment ago that is what containers are, those are the business benefits, right? Fast, portable, lightweight. They enable you to do more things that you just could not do before, right? So containerization in and of itself isn't necessarily the end goal. And I see this, we actually see this a lot with our customers, right? We have people who want to come to us and say, well, I need to containerize because it's cool, or I need to containerize because all of my competitors are containerizing. Those are not great motivations to do this, because in and of itself, it doesn't give you anything, right? If you took one application and containerized it, well, okay, great. It's now a containerized version of the same thing. It's what you can do next that was where the real business value is and what it enables you to be able to do and grow into.
Yeah. So here are just some examples of how you can take the same image and run it on different sort of products that Google offers. And these are completely sort of portable between one and the other. So you can take the image, just deploy it to Compute Engine with a gcloud command. You can use Kubernetes kube control to deploy it to a Kubernetes engine cluster, or you can deploy the same image to an App Engine instance.
So that's 3 different hosts, 3 different targets for the same image. It's really that easy. 3 different commands, and you've got the same image running on 3 different things.
So you have more options. So what do we do with those options? What are the different choices of runtimes, and what do they mean for us?
Right. It's a change of problem. Before we had the problem of how do we make the VM as good as possible. Now we have a question of where do we put the container? How do we choose the right home for that container to get the maximum value? The good news is if you get it wrong, it's that easy to change to a different one. Right? 2 commands and you're back to where you were. So it's fairly low risk of a decision to make. But it does mean that we can use the different advantages of the different platforms for their actual business value, rather than just because it's what's technically compatible with what we have.
Yeah. And the way to look at it is, if you look from left to right, the options on the left end of the spectrum give you more control, but the downside is they come with the overhead of you managing your own infrastructure. So you have to manage your own VMs, and it's sort of an overhead, but that's what a lot of organizations are used to, so it's a more familiar world for you. So you can start there, start with Compute Engine and run containers on Compute Engine, and then you can graduate to different other offerings. As you move along towards the right, the offerings are more managed. That means that you have to spend less resources managing those offerings. And for smaller organizations, startups, that's typically they don't have the extra resources to manage the infrastructure. So that's why we see a lot of startups start on App Engine. And it's geared towards that.
And I'm sure you've heard that a lot this week and at Prior Next and other Google events. We're forever talking about freeing up your developers to do what's meaningful, right? Where the actual business impact is. Keeping the lights running on a VM probably doesn't make your business or your customer's business money, right? What makes the money is building new innovation, innovating new things, creating new opportunities for your customers, for their customers. And so freeing up your developers to do that is great. And this is what we're trying to say here is that by containerizing, we can get even closer to that dream of minimizing the amount of time and money that we've spent on these things which don't generate that business value.
Yeah. And the sort of the trade-off is, as you're moving towards the right, you're giving up some control. When you're running in a managed environment, you have to understand the environment that you're operating in and maybe change your application accordingly to take advantage of that. So even though staying on a more sort of self-managed platforms gives you more freedom, moving towards the right side gives you sort of more flexibility and less overhead.
Exactly. Okay, so that's a lot about what containers are, why you should use them. Now, to the true value here, how do we get there? How do we go from nothing to something in the world of containerization? Now, the key to this is it doesn't have to be everything at once, right? There's no sledgehammer that fixes this walnut, right? We want to break down the problem into different components and tackle each one of those components one at a time. And so the first step today is, what have I got and what category does it fall into? Inventory and classify. Now, inventory, as I'm sure you know, is not straightforward. Doing an inventory of every application that you run or your customer runs is very, very difficult. So we're not necessarily suggesting here that we want to spend all of our time talking about inventorying every application right down to the tiny little ones that are barely used and hiding in the corners. The real meat here is in the classification. So find the 80% of the applications and then focus in on those to see which ones of those we can use in which wave. And we basically said there are 3 groups, right? Group 1, we're talking about stateless applications. Things where we don't care, we don't need to remember what happened last time around. So classic examples, web front ends, some microservices, APIs, but anything where the current request doesn't need any context from the prior request. These are great candidates for containerization. Yeah. They should be, once you've found this group, this is the first group. This is the first movers. This is the thing that is the easiest to do and will give you the most impact straight away. So finding this category is the place where you want to be to move quickly.
Yeah. The second group is what we're calling the second movers. These are applications that have some state, but the state is temporary. Even if you lose the state, it's not a big deal. Like caching is a great example of that. When you start a caching application, it doesn't have anything stored in it. You build up the cache as the application runs, and then it's useful that you can look up that things that are cached already. But if if you had to restart it, yes, you lose some the agility of being able to look up things from the cache. But it's not the end of the world. You can restart and start over.
Yeah, it's an accelerator, right? They accelerate performance, but the actual data loss is not critical.
Yep. Other examples in this category would be things that have like a master-slave component sort of thing, where one instance is the master and there are separate slaves. So again, each instance is not the same. There is some state that is sort of unique to each instance. So those kind of applications are again a little bit harder to not containerize, but run effectively in a containerized environment. Creating a container is not as difficult. The challenge comes from actually managing it in a containerized environment, running it in a containerized environment.
And then there's group 3, the hard group, the stateful applications. Now, you'll hear lots of people say, don't run stateful applications in containerized environments. It's good guidance. It's not because you can't, and it's not because there's no value to doing so. It's because it's hard, and the value is minimal compared to the other things. So anytime you find one of these stateful applications, that goes in tier 3. It goes in wave 3, right? Yeah. It can be done. Yes. Some good examples: storage, databases, right? Containerizing a MySQL database is not necessarily the easiest thing in the world. It can be done, but there's work, there's process. And if you think about the reasons for containerization, talking about ease of scaling, the performance savings, things like that, a database doesn't lend itself as easily to that as something like a web front end does. Yeah. And again, it's very possible, it can be done, but it's definitely lower on the list of priorities when it comes to investing your employees' time and your time in actually building and changing that application.
Yep. And if you think about it, you can't just instantiate another database and expect it to sort of work seamlessly. There's a lot of work that goes on to make the replication and other things work across these kind of applications. So the benefits that you get from containerization of ability to scale up quickly and scale down based on demand is not easily done with these kind of applications. So that's why we're saying that this should be the lowest priority.
At the end of the talk, we'll come back to some examples of where you can see this done the right way, that you can go and look at if you do get to that stage 3, that group 3.
Yeah. So that was the first part, is to inventory and sort of classify your applications into different groups. The second part is, how do you now start containerizing those applications? So we'll go through a number of examples, and the great thing is that you could be anywhere along this journey. This is typically how organizations start. A lot of organizations might be running what are called monolithic applications. Mm-hmm. So you have one sort of application that has the front end and the services, everything in one runtime. maybe like a Java enterprise application that does everything is an example of that. So those are typically called monolithic applications. And you have a database where you store some of the state, and then the monolith runs both your front end as well as the application. So you can containerize it. So the part to containerize is that monolith. And the positives of that are, this proves the concept. If you're just starting on this journey, it shows you that you can containerize. And without investing a lot of effort in re-architecting, you're proving that you're getting familiar with the containerized world, and proving that you can manage it.
On the other hand,
yeah.
as mentioned earlier, you now just have the same application that is containerized. It's running in a container, but it's pretty much exactly the same. So there's actually minimal benefit to doing this. The primary piece is that it's like practice. It's an easy win, right? We can take one thing and say, oh, hey, cool, I know how to containerize an application. Yeah. And there's learning and merit in doing that in and of itself, but it doesn't really give you the scalability. Like, the chance of that then becoming very scalable just by putting it in a container is very slim. So you haven't got those full business benefits we've been talking about, but you have proven, hey, I know how to do this, I know the technologies, I know the tools, which gives you confidence when we move on to the next type.
Yeah. So then the next step along the journey, and you may already be here, is, as we mentioned, that you have to take out the stateless portions of your application and sort of containerize. So containerize them separately. So what we're doing is, this is sort of a 3-tier design where you have a front end separate from your back end, and then you have the database as well. So this might be the next logical step. And in this, you would, again, do well to containerize the front end and the back end separately in separate containers. The box is not meant to show that you put them in the same container. You put them in separate containers, but that's the portion of your application that you should start looking at containerizing. And again, the positives are you can scale the tiers individually. If you have a lot of front-end requests, people are just maybe browsing and not interacting with things that require back-end services, you can scale that up and down independent of the services. Again, the drawback are that you're not getting the full benefits. This is still not scalable. But the great thing is you're getting closer to the microservices architecture, which is, I guess everybody loves that and wants to go there. So the great thing is that containerization sort of forces you towards that architecture. So going along this journey, you'll end up with a number of microservices along the way.
And each of these application architectures we're showing here are moving increasingly away from the monolith, increasingly towards the microservices model. And the idea here is we'll show at each stage where we can apply that containerization technology and how that enables us to move further down that path. So it may be that you or your customers have started off at the pure monolith or any one of these architectures down the line. What we're trying to say is there's a journey and a path forward that you can enter in at any of those places. So this is one, the 3-tier. Yep. The next one would be if you have a transitional microservices architecture. So it's like a traditional 3-tier application, but now some of those back-end pieces are broken out as their own service. So in this particular example, service A, maybe it's authentication, maybe it's the item library, catalog, whatever it might be, has already been broken off as its own service. It hasn't necessarily already been containerized. It may be just running in a VM or a few VMs or something like that. That is a great candidate for containerization. Yeah. We're now talking about the ability to take that one service and scale it up and scale it down very easily, move it across different platforms, reduce overhead, increase security, et cetera, et cetera. And we're creating, by doing this, a pattern that we can then use as we move further down the microservices path. You can think of it as a toe in the water of microservices architecture, right? You don't have to touch the existing monolith. That remains unchanged, so there's minimal risk in the application. So if this is a business critical application that's actually generating the revenue, there's minimal risk in doing these changes. Yeah. However, that's a good thing and a bad thing, right? Because now we still have the monolith. There's presumably a reason why you want to move away from the monolith. Whatever that reason is, this doesn't solve, right? It's a step in the right direction, but you're still left with those problems that you had before.
Yeah. And the other great thing with this approach is that now you're not re-architecting the whole thing at once. Your existing applications continues to run and be useful, and you're transitioning slowly to this new architecture, so you have fewer disruptions. And you're learning as you're getting comfortable in this new architecture and the containerized world, you're learning and it's sort of spread out over time, so your risk is reduced as well.
Exactly.
Yep.
And then the next step towards microservices, you can add an API gateway.
Yep. And then what you can do is, one pattern that we see that is very useful if you're going in this kind of a journey is to add an API gateway. API gateway sort of hides the services that are at the back end from your clients, which includes your front end as well as some clients might directly be connecting to your services. Like if you have a mobile application that runs, that is not a browser-based, it's a native application, it may need to call services, and if it goes through the API gateway, then it doesn't need to know exactly how the services are laid out at the back end. So it has a number of advantages, so that might be the next logical step that you introduce into your architecture. Add a gateway, which will hide the details of the endpoints of actual services, and as you move them around, it doesn't matter whether the response is coming from your monolith or just the new service that you've added. The clients don't have to know that detail. And that way, you can easily change the service endpoints. You can introduce a new service, you can move it around, and so on and so forth. The drawback here is that you need to build this sort of gateway, and this is a common pattern, though, that we see in the industry. So there are a lot of examples out there, and taking this step shouldn't be daunting.
And it's not wasted effort.
Yeah.
Right? You're in the dream state, fully microservices architecture, you may still want to have the API gateway. So this is not work you're going to do and then throw away. It's work which is useful later on.
Yep. All right. And then you can build on that pattern, and you can scale out sort of your services. You can keep taking sort of services out of your monolith and keep putting them into new sort of service-oriented architecture. And this is an approach that a lot of people recommend, even if you're starting with a new application. Even if you have a greenfield application, there are two sort of schools of thought in microservices. Some people believe that you shouldn't start with microservices. You should build them as you need them. As your use cases are seen, you truly realize what services you need. If you sort of theoretically start with some services that you think you might need, that may not be the right division. So this sort of allows you to sort of move into this microservices architecture, at your own pace.
And in the dream world, this legacy backend goes away, right? And the dream utopian future is everything's a microservice and we're in a full microservices architecture. The reality in the field, at least that we're seeing, is that doesn't really work. There's always some element, or usually some element that needs to remain. Maybe it's some hardware that you can't move to the cloud or move to your microservices. Maybe there's some legacy software which has some licensing requirement that you can't meet in the new world. But what we're targeting here is the 95% of the functionality of the application moves into these microservices.
Yep.
Now, does anybody recognize this pattern? Has anyone seen this before? Does anyone know what we're talking about? Shout it out. Shout it out. Louder. My hearing's terrible. Yeah, you've seen this in the field? I'm going to go to my plant, who I know knows the answer. Strangler pattern, exactly. So those of you who've seen this before, the principle goes, right, if you have a great big tree, right, that's been standing for 100 years, and there's vines growing around it, right? Each one of these microservices is the vine. Eventually, when the vines are big enough and complex enough and strong enough, if the tree dies and rots away, the vines remain in its place. And it's a really nice analogy for this, right? We build the microservices around the monolith until we have replaced all of its functionality, or 95% of its functionality, at which point we can shut it down, turn it off, or turn the vast majority of it off, and we're left with this true microservices architecture. And in our professional services group, in our application development specialty group, we use this all the time. This is our go-to-market, so to speak, with our customers, where we will pitch this idea and follow it through with them, where we can actually start to replace the giant monolith with beautiful microservices architecture, built around containers with containerization, Kubernetes, GKE in most cases, where we can actually start to remove and replace that monolith.
This gives you another sort of insight into when you have these microservices running sort of independently, you can choose different products to run them in. You might run your front end in App Engine, for example, and run your back-end services in Kubernetes Engine. You might have some services deployed as cloud functions. So it gives you the ability to sort of pick and choose the appropriate technology to run your actual application in. So that's sort of another
Exactly.
Idea around that. Yeah.
And you get all the benefits we talked about in the microservices architecture, right? Scale different services, implement new services, replace existing ones. It really gives you those three things we talked about at the beginning: the lightweight, the fast, and the portable. Whilst they are elements of containers, they are what we're striving for in a microservices architecture as well. The two things, I often hear our customers will say, well, microservices and containers means the same thing. It's not the same, but it's very closely related, right? The two go together hand in hand very nicely. You can do one without the other. You could do containers without microservices. You could do microservices without containers. But the two, when they're done together, gives you the most value.
Yeah, yeah. And I guess the third step is to sort of reap the benefits of this new state and and enjoy the microservices architecture.
Exactly. So I mentioned earlier, as we got towards the end, we would talk about some examples of stateful applications running in Kubernetes. We actually have a whole bunch of other things. So something that we're seeing out in the world with our customers and with our partners is that there is a large request and desire to have example applications and workshops to go with them so that a customer or a business can understand, how do I do X with GKE? And when I say X, I mean different things. So how do I run GKE in an application in GKE in production? How do I handle networking in GKE? How do I run stateful applications in GKE? And the more we've seen those questions come out, the more we've come to understand that we needed something from the professional services viewpoint in addition to everything that we had. So we came up with Project Helmsman, and I'm very pleased to announce that today is the first day that the Project Helmsman code is released into public open source. You can all go check this out straight after. In fact, you can check it out right now if you wanted to. Straight after the talk, you will be able to see it at this URL here. The idea is we've come up with code samples, and there's a few folks sitting here in the room who've been very heavily involved with this, so thank you very much to you all.
Yep.
We now have open source proof of concepts for all those things I just mentioned and more. We have matching presentations, which are available to Google's partners today, with more to come, that allow you to walk through a one-day or half-day workshop of any one of these particular things. So if you or your customer has a question, how do I actually use GKE in production? We have an example, and we have a workshop to work through it. There will be more. Watch this space. We'll be releasing more and iterating on these as time goes on.
Yep.
But I hope that this generates a great deal of value for you and for your customers that enable you to really start to use GKE in the way that we hope it can be.
And we've tried to take real-world scenarios. I know these are sort of samples and examples, but we've tried to sort of root them in reality in what actually the customers need. So we have also covered a lot of hybrid scenarios where you might be still running some applications on-premise outside of the cloud. So it covers a lot of different scenarios. So I hope you find it useful. Yeah.
Absolutely.